Okay, so for the people who are joining us online, basically, when you look at a question like this, a lot of people will look at this, not be sure how to go about it, and then think, okay, well, it's some kind of inequality, some kind of graphing, it's probably some kind of fraction, and all we've done this chapter is graph, so I'm going to just do DIAC. If you are doing DIAC for this question right away, just blindly, it's not the worst way to go about it, but it clearly shows one, there's a lack of practice. Number two, you're still memorizing math. Okay, let me try to break it down, and then you can try it on your own time, because I see that half the class is getting it, so I don't want to get them to do the same stuff again. First, it's asking you to solve an expression that is just all over the place. And maybe you can, maybe you have some ability in your head, maybe you're a savant, or maybe you have other strategy that you learned somewhere else that gets you to solve this. But if you are not quite sure, the only thing we have learned how to do for inequalities is turn all of this into one fraction. Right? Every single time, like every question we've done, even if it was just a graph, it was always something over something. There was nothing else afterwards. In fact, the only time there was something afterwards was a remainder, which turns into a zero anyways when we look at end behaviors. So your first goal in a question like this would be to turn it into one fraction. I'm going to bring everything to one side and turn it into zero. That would be, I'm going to rearrange, so 6 minus a 7. 6 minus a 7 is a 1. So there's that. Okay. And you can still try to solve this, but you can't. You can't. How do we change this, or how do we turn this into one fraction? You're subtracting. You're subtracting a fraction. Right? Sorry, I forgot this. And in short, if I were to subtract, the denominator remains the same. This becomes negative x plus 1. This is there. Keeping you on your toes, right? It's not my fault. That was totally on purpose. Okay. So here's where we check. That is not even a grade 11 thing. It's just fractions. Now, a lot of people might not like fractions. I understand that. That's why the main thing I ask elementary, middle school students, middle school teachers, to say, forget all the math. Get your students to come to high school with a good understanding of multiplication. So know your multiplication tables and your fractions. With that as your building block, all the other math that you use conceptually can be learned in high school. You can. With extra hard work. But anyways, please don't be afraid of fractions. When you get to this point, now you're thinking, okay, when does this equal? When is this equal smaller than 0? When is it a negative number? There's a couple of ways you can do that, and guess and check is one of them. But if you think about one of the tools that we have worked on, it is something along the lines of this. Where at the end of the day, you learn when the fraction is a positive number or a negative number, so on and so forth. And so if we are able to get to this, we can solve this. What do we need for this? Yep.
On the left side.
Yep.
31 minus x.
Okay, we'll have these two. What about the top?
Isn't it 1 and 31?
Yes. What is 1 and 31?
Oh,
Vertical asymptotes and x-intercepts. So you're going through DIAC not because that's all you know, You're doing this because you're trying to hunt down the vertical asymptote and the x-intercept. That's all I care about. Why? That will tell me when it's positive or negative. And my answer, the negative portion of the answer, is going to answer the original question. So it's a lot to deal with. It's a lot to keep in your head. And that's a shameless plug into why people, large programs, even business, ask you for math. It's not necessarily because they want you to sketch a function. When's the last time you're going to get an equation to sketch in business? But it's the fact that you can consider multiple things and juggle these things all at the same time so you can come to the right answer. If anyone here has ever event planned, if anyone here has ever hosted a party and planned everything from scratch, if anyone here has planned a camping trip for summer camp for your kid, if anyone has done any form of organization, you have to juggle a bazillion different details. What do you think you're going to do as an adult? Taking care of other people's money. It's the same idea. That's why they want math, not because you can do plus and minus, all right? Please, can try, make an effort to juggle. What is it that I'm trying to do, and answer those questions for yourself. If you can't do that, then there's no point in learning inequalities. It's not about the inequalities, right? Your future has nothing to do with inequalities. It's about being able to consider all these things at once. So, domain, I don't really care about that, do I? I'm going to go straight to intercepts. I don't care about the y. When is this going to be equal to 0?
It's 31.
X is 31. Good. Asymptotes. I don't care whether there's a horizontal asymptote and a vertical asymptote. Right? I mean, sorry, I don't care if there's a horizontal. I'm looking for the vertical. So up here, I'm going to have a 1 and a 31. I'm going to have negative x plus 31. I could have factored that, but whatever. X minus 1. Throw a 0 in there, I get a positive. Throw a 0 in there, I get a negative. That's going to be minus. A number between those two, I'll use a 10. Positive. Negative. Huh. Wait. Oh yeah, positive, positive. And then I'll do 100. That's going to be negative. That's going to be negative, positive. Okay. So it seems this is going to be a negative in this interval and this interval, which means the original equation is going, or original expression is going to be less than a 7 in those same intervals. Therefore, I'm going to just say 6 plus 30 over x minus 1 is going to be less than 7 when x belongs to negative infinity to a 1, but I don't include a 1 because this is not equal to union 31 to positive infinity. And you can't see that last part, so I'll just do that and let you catch up if you're online with me. Small details with a goal in mind. So think about this. The reason why I'm getting you to try this as an exercise, whether you fail or not, is for you to understand that the goal of math isn't just being able to solve the question. There's a lot more to it. The biggest issue, even amongst my what I'm going to call the most, like in my other class, even the students that were very proficient and very confident in their math felt like the amount of time I gave was a little challenging. Not impossible, but they felt the crunch. And they told me about it. And I was like, why would you feel the crunch? And when I took a look at their work, and I realized why. A lot of their time was wasted because they were doing things they didn't have to do. Not that that's bad. In fact, If you are doing calculations you didn't have to do, I would hope that you're so good with it, you're so fast with it, that it doesn't really matter in the first place. But if the calculations you do are like nice and slow and make sure you're not making any mistakes and blah, 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 well, you know how the people in the internet are like, oh, don't work harder, work smarter. This is an evidence of working smarter. You're only doing what you need. But if you don't know how to work smarter, then you better be working harder. Okay, just trying to give you examples here. Any questions? No? Okay. Then how about I give you another example and see whether you can work either harder or work smarter about it. This time I'm going to give you an equation. This is still from chapter 3.4 because, I mean, yeah. Medium or hard?
Medium.
Oh. I don't know if I want to spend that much time because I want to finish this review before the break, before our break, and come back on and have a small 30-minute lesson.
On chapter
4.1. Yep. Trust. It's okay. It's okay.
What's the 4 on?
We're moving on to trig. Come on, people. 2 periods of review? I don't think so. All right. Okay. Working harder or working smarter, okay? I'll change the video in just a second. Okay. Okay, this is like medium hard, okay? I don't even consider it like hard because since this being I don't know, stuff you've seen before. No, it's like all of these questions, more than being hard, it's just annoying because it takes a long time. The math behind it should not be difficult. It's just annoying because you have a lot to do. So again, for the sake of time, working harder or working smarter? If you're working harder, be fast. If you're working smarter, just go directly to what you need to solve. Solve. That's it. In other words, what value of x makes this equal to a 1? Oh, I can start the time. All right, 10 minutes, okay? Let's do this. You can do it. Go. You can do it, my people. This is not an inequality. Again, if you're looking at this as if you're going to use the previous example to solve this, you're still memorizing math. Look at the question individually, figure out what they're trying to ask. Go hunt down the things that you need to solve this question. I mean, don't get me wrong, some parts could be similar, right? Some parts could be similar. If you follow step by step, you'll be like, why am I doing this? You'll get there. Don't do that. Yep, it's time. You have 9 minutes. See what you can do. Yep. Think careful, even if you're not sure, And now that you see the question, it's like, what could I do? It's a huge skill to have. No, I just can't do it. It's not how. I sure. You could, but again, there's a truck line. So. Okay, so we need to make this equal to a 1, which is very challenging. And then if you bring this to the side, you want to know when x equals 0. You probably see it beside the right side. You'll know what the x values are. Challenging. Well, that was the exact same thing. Yeah. Okay, so you have that's a plus 3 and a plus minus. You only need to make them together. You're going to have to have a common denominator. Yeah. So the denominators will be 2x plus 3 on both sides. Yeah. So this is correct. Exactly what you're supposed to do. And then that 1, it's correct to bring it to the other side.
Yeah, that's even minus 1. Oh, think about it. It's a negative.
Absolutely right. I know, I just thought that. 4 positive 12. So negative, more positive negative to add positive. Let's do this already. Product formula. And then. One.
No.
So again, annoying, but not impossible. Yes. Okay. Okay. Yep. Yep. Yes, yes, yeah, you can do that. Okay, well, it's not all of these. These come on. And then whatever you find here. Like, just because I have this, when am I multiplying this to both of these? Oh, you only multiply this to this. Same thing. Multiply to whatever's next. No. You mean like that? What's smarter? What is asking? Not an inequality. How much? There you go. I'm gonna solve it now. Wait, how much time do we have? Oh, 3 minutes.
Yeah, you're right.
Get the same thing. You try to find
Zero equals negative.
Well, because the numerator can, I mean, if the numerator.
All of these things are.
Yeah. I mean,
You have this is perfect. What's your one? And only way you can solve it is if one side is zero, minus zero. Right here, which means that. Oh, did you? Okay, perfect.
So,
Then, yeah, once it is plus 4x squared,
yeah.
so whatever this comes in. You are correct. You're looking for one thing. You don't have to be. Yes.
So minus that.
Well, just, I mean, yeah, or you can.
Then I am right. That's my initial. But then I am right.
Yeah, that would work out. There is a way to make the denominator the same. Why not multiply? For example, if you have
I collected.
1/3 minus 1/3, how do you solve it? You multiply this by 2 as up as well as. You multiply that by 3. In other words, you multiply the denominator. On this, it's going to have to multiply. In other words, multiply by 1. And this would have to use the denominator.
But the quadratic. I think I'm gonna.
So I just.
Oh my God.
The thing is, I'm like, I know how to do that, and I thought about that, and I was like, yes.
So you multiply negative number.
And there's that age-old saying of learning from mistakes. That all those frustrations and tears need to happen not in the classroom. In grade 12, there's no other way around it. And that sounds terrible, but practice is so important.
So what does that equal negative? What?
One. Amazing. Is that time? 5, 4, 3, 2, 1. Okay. Is it focused properly? I hope so. Okay. All right. Same as before. As far as we care, or as far as we know in chapter 3, the only way we can solve this is by turning it into one fraction, one equation, right? Like one fraction, not equation. So I'm going to go about doing that. And yeah, it's really annoying. But that's the only hard part about this question, at least in my opinion, if you know what's happening. To make this the same denominator, I'm going to multiply this by 2x minus 3 and 2x minus 3. Because if I do that, the denominator is 2x plus 3 times 2x minus 3. And the top is 2x times 2x minus 3. At the same time, I'm going to multiply the numerator and denominator by 2x plus 3, 2x plus 3. And in case you're wondering why that's the case, because you're not familiar with fractions, you can multiply by a 1 and anything is okay. Right? If I multiply by the same thing on top of our numerator and denominator, we're multiplying by a 1. While that's happening, because I am lazy and I don't want to write another line, I know at some point I need to move this 1 to the other side because I need one side to equal 0. So there it is. So let's simplify. The denominator, again, mathematically, I am way too lazy to write both of these. I'm actually going to write it out. Actually, maybe that's not the best practice. Okay, I'll write it through. And then top is 4x squared minus 6x minus 4x squared plus 6 minus 6x. And then minus this over this, right? It's a 1. Yep.
Plus 6x.
I know it's a plus 6x, but I'm subtracting. So I'm going to do it all at once because I'm lazy. And again, this is going to be 2x plus 3, 2x plus minus 3 over 2x plus 3, 2x minus 3. Quick point. This is just a regular question in the textbook. Okay, just letting you know. It's not some fancy thing that I developed. Okay, final line becomes 0. This becomes a negative 12, but I am subtracting by this as well. So again, I'm going to skip a couple of steps and just do the calculations very quickly. This will become negative 4x squared. This becomes nothing minus 12x. And this becomes a negative 9 plus a 9. And at this point, after all that annoying work, you will see why we worked so hard to turn it into one fraction. When is a fraction ever equal to a 0? You're right, when the numerator equals a 0. So at this point, we can actually pretend you don't have to pay attention to this anymore. We're just looking at when the numerator equals a 0. It'll be nice to factor it, but from the class consensus, they're like, no, this is not factorable. So you're going to use quadratic formula to make sure there are no roots. It turns out there are. So I'm going to do that on the last bit, and then we've solved our question. Yes? Negative 9. You can. I was thinking of doing that earlier, and then I realized in other examples where maybe you can divide out. I didn't want anyone to get confused again, because some people still memorize their math. I just left it alone. Pardon me? Well, of course. Well, you haven't solved it yet. When is this equal to a 0? It's like saying, when is the numerator equal to a 0? Right? So all of this is actually still grade 11 rational expressions. Right? It's just manipulating fractions. The grade 12 portion, I suppose, is why the heck am I doing this in the first place? And that would be, it's all around, right? So moving on, I'm just going to check when is negative 4x squared minus 12x plus 9 equal to a 0. I could factor it out, but since I'm doing quadratic formula, I'm not even going to do that extra step. My A value is a negative 4, B is negative 12, C is a 9. Let's first check the discriminant to see if there are any possibilities. B squared, 4 times A times C. That looks pretty close. 16 times 9. Oh, it's a 0. Am I wrong? Oh, I was so happy. Dang, you're right. It's 288. Oh, I was so happy. I thought it was going to be a 0. Okay. Root 288. Nothing really comes to mind. I could simplify this. Should I do it? 4 is a 72. I can do a 9. 8. I could do another 4. There it is. Okay. All right, that means x is going to be negative b plus minus this over 2a. So x is either going to be negative b, so 12 plus minus, so plus 12 root 2 over 2 times a, so negative a, which is going to be 3 plus 3 root 2 over negative 2, and just divided. Or x is going to be 3 minus 3 root 2 over negative 2. So some of you are still rapidly copying hard. So questions like this, notice that I did not do DIAC. That's right, but they will guaranteed, there were last week, guaranteed there will be people who are going to be wasting their time doing calculations they did not need to do. And so when I gave this mini test 40 minutes, a lot of people felt it was tight. If you're going to work harder and be more proficient. But if you're going to work smarter, then work smarter. Either way, my expectation is that you all perform very well tomorrow. Question?
What I did when you taught the last line, I factored out -1.
Yes?
And then for the quadratic formula, it was just like +2 in the denominator and -3 in the.
Correct? Same
Oh,
answer.
that's okay.
Yes. Yes.
How do you do the whole 288 square root of that thing?
I'll do that in just a second. Levi? No? Okay. Ethan, you had a question?
I was gonna say the test only 40 minutes.
Pardon?
Only 40 minutes.
It's going to be 40 minutes. No multiple choice.
No more.
There's going to be no multiple choice. There's going to be plenty of space for you to show your work.
There's just a bunch of questions like that.
Well, use today as a reference. I asked you to do one of these in 10 minutes. 4 questions? 4 questions like this?
Yeah.
Well, I'm not going to have all my questions like this.
No, we don't like that.
But 4 questions, maybe. It's possible. So let me first address the square root simplification. And how about we move on to a practice for rate of change? Okay, so some people were asking about that. You'll see that rate of change is also, I saw a lot of people wasting time with rate of change when it's supposed to be super, super straightforward. Here's what it is. Okay, so to address your square root business, I'm going to move on. I'm going to try to approach this in a very quick grade 11 style manner. Okay. Okay, root of 288. Before I begin, Anna, you okay? Before I begin, I need to understand that if I have root 4 multiplied by root 4, I get root 16. Does that make sense? Which, of course, is going to be equal to 4, which makes sense because root 4 times root 4, you're doing the reverse. Yeah, anyways. That means whatever number is underneath the square root, I could rewrite it into its factors. So give me a factor of 288 that has a goal in mind. Give me a factor of 288 that can be square rooted. Give me a factor of 288 that uses any of these numbers. Go. 72 and 4. But that can be rewritten in separate square roots. So this is going to be square root of 4 times square root of 72, which is 272. Keep going.
I'm all right. I don't know, but it's big numbers, 36.
Yeah, 36. 36. Right? It's this. It's literally grade school where they're like, okay, give me a tree. What are the factors, right? You're literally doing it for square roots. It's the exact same skill.
So you go from.
Why should your elementary school teacher get you to do this exercise? And why should you have paid attention? It's all transferable skills, just like interview skills, just like interpersonal skills, all right? Just like all the other stuff when you go for a job interview. Same stuff. Okay, this is transferable skills in mathematics. Okay, any other questions before we do the interchange? No? Okay, I might have to get some help from the textbook on this one. It's transferring of board is challenging.
That's what they. That's what you do.
Okay, I'll skip all the frills and ask you, what is the average rate of change when x goes from, I don't know, okay, when the amount of coffee sold goes from 500 kilograms to 1,000 kilograms. And then part B, how about we do IROC? What is the increase in sales at 1,000? Or the rate, the increase in profit rather. Yes. Yes. For those of you who need a bit of a refresher of what rate of change is, it's literally calculating slope. So I don't know what this graph might look like. Well, I sort of do. Very quickly. Let's see. Turns into 0 when I get like a 50. And then when it's a 0, it's negative 0. What? When x is a 0, I get negative half. Something like that. So I'm guessing it's going to be something like this then. Horizontal asymptote is at 4-ish. And I'm gonna take a guess here. It's gonna be something like this. It's a terrible curve, but it is what it is. I think it's gonna be something like this. I just did it in my head. DIAC. Don't worry about it. That's not important.
Showing up.
No, it's practice. Okay, I practiced a lot.
I can do them.
Okay, it's fine. It's fine. Just got to practice it. I'm not even kidding. You think I was born with the skill? It's because I had blood, sweat, and tears. No, no, no. Don't tell me I'm smart. I was like one of the worst students when I was in elementary school. Okay, well, not worse, but I was subpar. Let's say. Did I tell you about my story of UTS? Yeah, I did, right? Yo, I sucked. I got angry. My dad yelled at me. I got sad. Very sad. Single tear dropped down as I laid down in bed. Okay, playing sad songs, thinking about how sad I am and my life was so bad. And then I got angry and I worked harder. And look at me now. Guys, let's finish it in 10 minutes and go for a walk, okay?
Are we gonna do it like together?
Okay, as a recap, rate of change, as I said, was just slope, which is going to be, a change in y over the change in x, right? Which means we're trying to figure out 2 points. Let's pretend right here and right here, and figure out what the slope is between those 2 points. It's literally it. And they give you an equation. And you can do it.
This is for the actors, right?
Yes. That's this one.
Yeah.
Okay. I'm gonna give you just
What is X?
about another 3 minutes.
What is X in terms of?
X is the net kilograms of coffee sold.
So it's in some graph, what is X on the graph?
As I sell more coffee, my profit goes down. That's basically what it is.
Almost.
For the X,
Yeah,
of course.
like 500.
Timing is very important. So yes. You need to know what numbers you need to put in.
Any questions on the mini test?
I actually don't remember. Let's put it this way. If you know how to, if you're not memorizing math, this will be like I asked every single math teacher, like, how did your students do it? Or how did you feel about it versus how did your students do? We're all like, it's like the easiest, it's a very straightforward, no special, bells or whistles questions from the textbook, and students were struggling and they were really tight on time. And that's why I decided to do this as opposed to just give you questions to try. I wanted you to press, or I want to press the matter of timing onto you. Okay, 30 seconds. Okay, let's do this. So as soon as, for me, again, working smarter here, as soon as I see this question asking for a rate of change, I'm literally looking for 2 points, right? It's a matter of where they come from. The question specifically asked in this case, what is the rate of change, or the secant, right? From 500 to 1,000. So I am going to figure out what my point is when x equals 500. And that will be 2,000 minus 200, 500 plus 400, 2. I didn't plan that. That was actually like totally right. That's pretty cool. Anyways, P, is it recording? Okay. 1,000. So 4 times 1,000, 4,000 minus 200. 4,000 plus 4. Oh, that's not as pretty. 19 over 22.
1,400.
1,400. Oh, my bad.
No.
No, it's 19 over 7, which is approximately 2.5 over 7. 7. Just 7. Okay, approximately 2.7. All right. So slope, in other words, delta y over delta x, is going to be 2.7 is my y when my x is 1,000 minus. My y value is a 2 when my x value is a 500. So we have 0.7 over 500. 1,000, that becomes 1.4, 0.14. Right? Oh, 0, 0. So let's just multiply that by 2. That becomes 1.4 over 1,000. You're right. Okay. So if that is the case, what does that tell me? Remember, the slope represents a y over x. What is my y? It is my profit in thousands per, what's my x? Kilograms of coffee sold. So this many thousands of dollars per 1 kilogram of coffee sold is my profit. It's my average increase in profit. So 1, 2, 3. It's not the best. It's $1.40 per kilogram. I am profiting this much on average as I move from 500 to 1,000. That was my rate of change. My profit was increasing by about this much per kilogram. Sorry. Questions with this? Well, first, questions with the math. Questions with the meaning. Okay, this is the last part. IROC at 1,000. So again, we're looking at delta y over delta x. Let's change the camera a little bit. Oh man, it shut off on me. All right, there you go. Okay. I need 2 points. To be able to calculate the slope of something, we need the 2 points. Where is the 2 points coming from? Where are the 2 points coming from? One is 1,000. Yes.
Gram and then kilogram.
Because now it's like kilogram, and it's like different numbers.
Like kilogram.
It's in 2,000. Yeah.
I know. So when I calculated the slope, it was $0.0014,000. Right? And so I just 1, 2, 3. It's $1. So this is already in thousands of dollars per kilogram.
I'm so confused. Why is it $1,000? Is that the question?
Yeah, the question said, profit is in thousands. So whatever that number is represents thousands of dollars. So I just revised it to become regular dollars. Sorry about that. I just, again, that's why I asked, like, everyone okay with the meaning? I'm looking for the profit when it's 1,000, because I already have that 1,000. How much would it increase by if I sold an extra tiny bit? I want to see what direction we're going. So I would have to plug this in. This would be which would be and I need someone's help with the calculator. And I'm afraid that it might be really close to 0.7 again. That's why we need as many decimal places as possible. We might have to revisit the decimal places of when we use just 1,000 and not 1.7. Okay, 2.7142. 866. Okay, that should be enough. Could we go back to the profit when it's just 1,000? Can you do 19/7 again for me?
2.71.
Uh-huh.
857.
Wow. Okay, that's going to be enough. So my IROC at 1,000 is going to be 2.7142866 when I use 1,000.001 minus 2.7142857 when I use 1,000. IROC. And once you calculate that, because of that slight difference, you should see some kind of value. I don't know if it's as big as 0.0014, but this one, 5.7. Oh, that equals 1, 2, 3, 4, 5, 6, 9. 1, 2, 3. Oh. Yeah, so it is smaller. It's about 90 cents per kilogram at that point. You don't gain as much profit. Yes.
And then do you have to use the thousands to get to move it?
Yeah, so this is the correct answer mathematically. So what does that mean? It means we earn 90 cents per kilogram sold. It's going up by 90 cents for every kilogram that we sell extra. Right, that's going to be our profit. It's not much, which makes sense. If you remember the graph that I sketched, we did have a horizontal asymptote. It's going to start to plateau a little bit. So again, IROC and AROC is just more calculations. As long as you understand it, there's not even anything to memorize. You've done slope already, right? So I hope that when you approach these questions that you don't think about it as, oh my goodness, it takes so long to do one question. It's home in on what you need to solve. Don't just reproduce every single question as if it was the same calculation. 0.0009 is the slope of y over x. In other words, what's the unit? It's $0.0009,000 per kilogram of coffee sold. Again, the question said it's thousands of dollars. So what is $0.0009,000? It's 90 cents.
Not the dollar.
Yes.
So how does it, if it goes up by 0.001, it's enough? 90 cents. 500. Only $1.40.
Also, it's gonna use.
Oh, no. Yeah.
I'll stop the video here and letting people catch up a little bit.